Hello, all of my lovely 7th graders. Welcome to Miss Nystrom's online learning. Today is Wednesday, March 18th, otherwise known as Hank's birthday. Hank is 2 today. Let's go over the warm-up before I show you great pictures of Hank. All right. So today's objective is I can draw a tree diagram to represent multiple outcomes. Maybe you've heard of a tree diagram, maybe you haven't. Either way, you'll figure it out by the end of this video. All right, Sarah is playing a board game. The probability that Sarah will score a point on her next turn is 1/3. So we already know the probability. Which statement best describes the probability that Sarah will score a point on her next turn? So we know the probability, and we have 4 words to describe it: likely, unlikely, certain, and impossible. So hopefully you're thinking, okay, I need to know, or I know what I need to do with this in order to figure out which word best describes it. And that answer is change this to a decimal, or a percentage, I should say. So to do that, you divide in your calculator 1 divided by 3, and you should get 0.3 repeating. But we need to make that to a whole percent about, so we multiply that by 100, and we get 33%. And if you remember, if it's not 0, it can't be impossible, and if it's not 100%, it can't be certain. And since this number falls below 50%, we call this unlikely. So the answer here is C, unlikely. Next up in today's lesson is showing you pictures of Hank on his birthday. He's 2 today, and he's currently sleeping on my lap. All right, moving on. Quick reminder to join my Remind app. Here is the information. All right, so let's start today's lesson. We are in 10.3 Compound Events Tree Diagrams. This is page 6 of your Chapter 10 Probability Notes. All right, so what we end up doing for tree diagrams is we end up finding the total number of possibilities of an event. So there's always different outcomes, different possibilities for probability. But for tree diagrams, we list them all. So this can be a pretty lengthy type of question, but I wouldn't say difficult. So let's start. It says Amy wants to pack enough items to create 6 different outfits. So we kind of know that she wants to create 6 different outfits. She packs 1 jacket, 3 shirts, and 2 pairs of jeans. What is the total number of outfits she can create? So in order to find out the total number of outcomes or possibilities, we make a tree diagram. So it doesn't matter what you start with. You could start with jacket, you could start with shirts, or you could start with jeans. This is not the best example, and I keep meaning to change it every single year, and I never do. But because there's not different names for each of the jeans, shirts, and jacket, they're all just shirts, jacket, and jeans. But again, it doesn't matter which one you start with, but I'm just going to start with jeans. Why not? So what you'd write is you just need to pick something to represent each of these items. So for jeans, I'm going to put jeans 1. A lot of times I just abbreviate, as you see, like I would just put J1, but because we have a jacket, I'm going to put actually jeans 2. And then jeans 2. So from here, after she picks a pair of jeans, she has the option of picking the first shirt, the second shirt, or the third shirt. So right now, an option for her is jeans 1, shirt 1, jeans 1, shirt 2, jeans 1, shirt 3. 3 options so far in the first part of our tree diagram. And then jeans 2, she also has all of these options. Shirt 1, shirt 2, and shirt 3. But she also has this jacket that she needs to add. Since there's only one jacket, it makes it pretty easy. I'm just going to put J1 because I'm getting tired of writing these words out. Oops, that's wrong. There's only one jacket, so it'd just be jacket 1. Okay. So again, these are all of her possibilities for outfits. She only has one jacket, so that's why all of these are just J1. Whereas she has 3 shirts, so we have to include them all, and jeans, she has 2 jeans. So again, these are your possibilities for outfits. She could wear jeans 1, shirt 1, jacket 1, jeans 1, shirt 2, jacket 1, jeans 1, shirt 3, jacket 1, and then so on for jeans 2, same thing. So that is a tree diagram. They call it a tree diagram because it kind of looks like a tree. I don't know. These are branches, and these are I don't know what they are. Maybe whatever the thing of a tree is called. Why can't I think of it? So along with a tree diagram, you have to make something called a sample space. Sample space is everything listed out. Usually abbreviated, never really not abbreviated, I should say. But I did write everything out, so however you write it in your tree diagram is how you should write it in your sample space. Now, your sample space is, again just a list of everything. So, jeans 1, shirt 1, and jacket 1. That's one option. So that's one part of my sample space. You should list all the rest of them in your sample space to complete your sample space. So I'm going to pause and fill it in for you. Okay, so I listed everything in our sample space, and that is where you count up the number of outcomes. So 1, 2, 3, 4, 5, 6. So Amy will be able to create 6 different outfits. All right, example 2. A car can be purchased in either blue, silver, red, or black. So that's obviously one of the options is color. It also comes as a convertible or a hardtop. So option 2 is convertible or hardtop. Try to tree diagram to find the sample space for the different styles in which the car can be purchased. So again, it doesn't matter which one you start with. I'm going to start with the shorter one, convertible or hardtop. So I'll put C for convertible, H for hardtop, and then from each one of those, there are 1, 2, 3, 4 different outcomes. So I'm going to have 4 different branches, and each one of them will represent each color. So blue, silver, red, or black. I'll use BL for blue, S for silver, R for red, and then I'll just use B for black. BL, S, R, and B. Now, as long as you know what your words are or your letters stand for, that's fine. Just don't use like Q for silver. Okay, so that's our tree diagram. That was simple. Now the sample space, again, comes from your tree diagram. It needs to be listed all of the outcomes, starting with the whatever this is called, then here, 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 1, 2, 3, 4. So we should have 8 in the end. So the first one would be convertible in blue, convertible in silver, convertible in red, and convertible in black. And then same for hardtop in blue, hardtop in silver, hardtop red, and hardtop in black. So in total, we have 8 outcomes or 8 possibilities. All right, I have 2 more examples for you. Example 3 involves tossing a nickel, dime, and then quarter. So tossing coins. You have to think about this because you can't write nickel, dime, and quarter, because what is an outcome of a nickel, dime, and quarter? That doesn't make any sense. So you have to think about when you toss a nickel, dime, or quarter, what do you get? Hopefully your answer is heads or tails. No matter what it is, nickel, dime, or quarter, or penny, or whatever, it's always going to be heads or tails. So those are your outcomes that you're putting in. So for the nickel, you have heads or tails. Then the second time I'm going to toss a dime. So still my outcomes are heads or tails. And then you have a quarter that you're tossing for a third time. So my outcome is still heads or tails. So the first one represents the nickel, then the dime, and then the quarter. All right, tree diagram wasn't so bad. The sample space is going to be a little longer. Now, I just want you to make sure you know where I'm getting these from. It can get confusing because everything was H or T. So make sure you're following through. So H, H, H. That means I got 3 heads in a row. Heads, heads, heads. Then heads, heads, tails. Then heads, tails, heads. And heads, tails, tails. And same thing for the next one. I'll give you like a minute. Try to write this on your own, and then I'll put them up. I won't give you a minute. You'll have to pause. All right, so tails, heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. All right, so we have a total of 8 possibilities, and then they're asking, find the probability of getting tails 3 times in a row. So you have to look to see in your sample space, how many times did you get tails 3 times in a row? The answer to that is just once, tails, tails, tails. That is 1 time out of a total of 8 possibilities. And I don't know, I don't have a calculator, so I don't know what that is as a percentage. 13 maybe? I'm guessing. All right, last example before you try some. We have Labrador Retrievers. Yay, dogs. The animal shelter has Labrador Retrievers, both male and female, and then you have the choice of brown, yellow, and black. There is an equal number of each kind. Draw a tree diagram to find the sample space. What is the probability of choosing a yellow female? Okay. So male or female. BR for brown, Y for yellow, B for black. BR, yellow, black. Sample space. The first one would be male, brown, male, yellow, and male, black. And again, this is where I got this from. Male, brown, male, yellow, and male, black. And then again, female brown, female yellow, and female black. So FBR, female yellow, and female black. Then there are 6 possibilities. What is the probability of choosing a yellow female? There's only 1 yellow female out of 6, and I know that is a 17% probability. Okay, so what I would like you to do right now is pause. There are some questions on the back, and I would like you to try them on your own. When you're ready to check your answers, then come back to the video. So pause the video now. And here are your answers. I don't have a lot of time left to record, so you're just going to have to look at them and double check it, pause the screen, and yes, have a wonderful